Hi, I'm Gabrielle, and I'm just going to give you a brief overview about the research we did on pesticides, kind of stemming more from how they began and like how they have evolved to what they are today. There is like traces back to 4,500 years ago of usage of pesticides from the Sumerians and then also from the Chinese in 1100 BCE. These are more so along the lines of they used arsenic and mercury based compounds versus, and like sulfur as well, versus kind of the more chemical aspects like we use today. Um, Also, there was like a switch from pesticide or natural pesticides to more chemical compounds as well. So the introduction of DDT. I am not going to try to pronounce it, but usage for plants came up around World War II when a Swiss chemist, Paul, I don't know how to pronounce his last name, Muller, discovered that DDT could be used also for plants instead of just for what they were using it for World War II to treat insect and crop related diseases. However, there were some major side effects among health issues and then also of killing off plants too as well. So they kind of moved towards more of the EPA, so the Environmental Protection Agency. It kind of came up about around this. Like their purpose is really just to ensure many different aspects of keeping U.S. citizens healthy and as well as the environment too. They also introduced MRLs, which are maximum residual limits, and that's going to be the amount of pesticide residue that can be left in on produce before they get put into stores. And then just like moving more towards today, we still face like a lot of pros and cons with pesticides because obviously there is groundwater contamination, harm to non-target organisms, which are going to be bees, like healthy polluters, or whoa, healthy pollinators, sorry, and then also just like plants getting used to them, so pesticide resistance. Thank you.
Let's jump right into it. I'll be talking about nanoparticles and their effect on plant metabolism and future regulations regarding such matters. The effects of nanoparticles on the growth, photosynthesis, and primary secondary metabolism of plants are both positive and negative, meaning some of these effects could be good, some could be bad. A lot of it has to do with the specific plant's interaction with the specific nanoparticle. So nanoparticles may interfere with plant metabolism, namely micronutrient uptake, oxidative processes, and gene regulation. Nanomaterials are involved in the expression of genes associated with antioxidant defense and hormone biosynthesis, basically meaning that these nanoparticles and nanomaterials affect the genes of the plants and some very important processes associated with those genes. So it's a lot of it sounds like we're playing God pretty hard. So we'll just have to take it step by step with that. Uh, Embedded single-wall carbon nanotubes in the isolated chloroplasts increase the photosynthetic activity by threefold compared to its controls. Similarly, SiO2 nanoparticles improve the photosynthetic rate by improving carbonic anhydrase activity in the synthesis of photosynthetic pigments. So basically, it had said, the article had said that the photosynthetic process is a good gauge for how well the plant is doing in terms of producing stuff. If it's very photosynthetic, it's doing very good. So by saying these nanoparticles increased photosynthetic activity threefold, they're saying in essence it made it 3 times more productive, which is very good potentially. Comprehensive reviews of nanotoxicity in humans, small mammals, invertebrates, and aquatic organisms have been published. However, studies related to nanotoxicity to terrestrial and aquatic plants are limited. It is unclear whether nanoparticles entering the plant system remain as nanoparticles or are biotransformed into ionic forms or other organic compounds. So basically, we don't know really what happens to them after they go in. They affect these plants on a very molecular level, and there's not a lot of studies talking about how it affects aquatic plants or terrestrial plants. So one study showed that 45% of the fed Fe2O3 nanoparticles accumulated in the roots and less than 1% were detected in the leaves. However, there was no uptake and transport of Fe2O3 nanoparticles in lima beans. Basically, these regulations would have to be very much specific based on the plant and the plant's interactions with the nanomaterials, because what affects one plant would affect another plant completely differently. Future studies should focus on addressing the key knowledge gaps and understanding the responses of plants to nanoparticles at all levels through global transcriptome, proteome, and metabolome assays, and evaluating nanoparticles under field conditions at realistic exposure concentrations to determine the level of entry of nanoparticles in the food chain and assessment of impact of nanoparticles on the ecosystem. Basically, we don't know what we're doing, and we don't know the long-term effects. We're playing God, and I think, in essence, I would say we cap it at about, say you can't change it more than 5% of a genetic level, have to have some sort of standard deviations, and say we can't go further than this many before we see how it affects it long term. And yep, that about do it.
While pesticides play a crucial role in protecting crops, their impact on human health is a growing concern for many people around the world. Acute poisoning. Pesticides can cause immediate health effects upon exposure. Symptoms can range from mild issues like headaches and skin irritation, or they can lead to severe health problems including nausea, vomiting, even respiratory distress. Agricultural workers and those who handle these chemicals are particularly at risk, facing dangers during application and mixing tasks. But the risks don't stop there. Chronic health conditions are another serious consequence of pesticide exposure. Long-term contact with certain chemicals has been linked to various cancers, including non-Hodgkin lymphoma and leukemia. It doesn't end with cancer. Pesticides can also contribute to neurological disorders such as Parkinson's, compromising overall health and quality of life. Children are particularly vulnerable. Prenatal and early childhood exposure to the pesticides can lead to neurodevelopmental effects. Research indicates that exposures may result in cognitive defects and behavioral issues. The risk amplifies concerns about the future well-being of our children, making it vital to address pesticide safety. The endocrine disruption. Certain pesticides contain chemicals that interfere with our hormone system. This can lead to reproductive issues impacting fertility and overall metabolic health for men and women. The implications are profound, emphasizing the need for increased awareness and advocacy for safer agricultural practices. While pesticides are a common part of our agricultural system, understanding their health risk is essential for advocating sustainable practices, and supporting organic farming can lead to safer food systems for everyone.